if you look at my history, I've kind of gone in and out of starting companies and working at large companies. And the thing about big companies is they have scale, they have structure,
Mhm.
they have capital, they have brand, they have a lot of really smart, talented people working at them. So, that experience is super valuable. And I'd encourage anybody, starting out early in their career, get a job at a big company for a while, so that you get all of that. Socialization is also another really important thing, I think, which is, I think, becoming sort of a generational issue. And then when you have those skills and you have, sort of enough cash in the bank, then, go pursue a startup idea.
Welcome back to Alexa's Input AI, and today I'm joined by Marc Austin, CEO and co-founder of Hedgehog, a company rethinking how we build and operate AI infrastructure at scale. Hedgehog is building an open-source cloud-native network designed specifically for AI, a platform that lets teams operate on-prem and hybrid clusters with the same usability and automation they expect from the public cloud. Instead of relying on specialized networking teams or expensive proprietary systems, Hedgehog gives cloud engineers a simple Kubernetes native way to run high-performance, multi-tenant GPU environments anywhere. So today we're going to talk about why AI infrastructure is hitting a breaking point, how networking has become the hidden bottleneck for scaling GPU clusters, what it really takes to make on-prem feel like cloud, and Marc's vision for where enterprise AI is heading next. So Marc, welcome. I've been excited to have this conversation with you.
Thank you for having me, Alexa.
So your LinkedIn title says GPU connective tissue. Can you tell me what exactly that means to you?
Yeah, it's kind of one of those taglines that hopefully explains what I do to my mother. If you're building an AI data center, or you are an AI researcher who's using those GPUs, they all need to be connected together, right? Because if you're, training a model, which is what a lot of people have been doing to date, and that model is going to train on shared memory from a whole bunch of GPUs. And so to do that, they need a high performance AI network. And when you get then to the natural evolution of that training and fine tuning, you have AI inference, which means that you need AI infrastructure at what we call the data edge, or the close to the source of the inference data. And that oftentimes requires a network for connectivity. So it generally describes what we do with AI networking in the context of what most people have top of mind right now, which is this GPU thing that enables AI.
Why is networking, or what about AI needs special networking considerations?
Yeah, so if we start with that training use case, in order to get utilization of these very expensive GPUs, where you have lots and lots of them to go train a model, you need effective bandwidth. So most of these are 800 gigabit per second, 800 gigabyte networks, and you want to get as close to that 800 gigabit throughput as possible. What happens though in an AI training workload is that the traffic on the network is sort of different than what previous applications like this Riverside application that we're using right now use. And so it creates, if you don't manage it correctly, it creates congestion on the network. And so there are techniques that you can use to manage that connection, manage that congestion so that you have maximum effective bandwidth. So what we do is we tune software on high performance switches that are connecting all of these GPUs together. Those switches have ports. It's a little, hole, you plug a cable into it. And on the other side, there's a couple holes in the GPU server that have a thing called a network interface card. And we tune the configuration of that network interface card and the switch in these really large AI data centers so that you get maximum effective bandwidth. And then the problem on inference is a little bit different. It's what I alluded to earlier, which is you need to have distributed AI infrastructure. So you're going to have lots of smaller data centers in a lot of different locations that are close to the source of the inference data. And that requires, a distributed cloud network.
So the GPUs here seem to be the thing that make it more challenging compared to distributed services that aren't AI workloads.
Yeah, I think it's fair to say that AI software runs in a totally different way than internet websites or B2B SaaS or mobile applications or, all the things that we've been familiar with in the past. The fundamental thing is that AI consumes a lot more infrastructure, and that infrastructure has very different performance requirements that are very difficult to meet.
Yeah, that makes sense. I like the way you broke that down. So a bit about your history that I was looking up at Cisco, you're head of automation strategy and growth. And then you're also head of broadband IoT products. You are also an investor. You were a managing partner at IoT Capital. So you have quite a bit of good experience. Can you tell me about your journey and how all this experience led to you starting a company?
Yeah, I mean, I'm kind of a startup junkie, honestly.
Really?
I'd say
What does that mean?
I think when I worked in my first startup in 1995, Internet Shopping Network. And once I got there, I just kind of fell in love with it. It was a pre-Amazon internet retailer. And I think I said at that point in time, it's like, yeah, there's kind of two kinds of people in the world. There's startup people, and then there's everybody else. So if you have that kind of personality, it's kind of hard to shake it. So yeah, I think you went as far back as like IoT. So this is the third company I've started, but along the way, I was working at the world's leading cellular IoT connectivity platform, a company called Jasper. And if you drive a car that has internet in it, and most of them do, odds are that car has a SIM in it, just same as a SIM it's in your phone that connects that car to the internet. So like one of our very first customers was Tesla. And they used that connectivity to then capture vehicle diagnostics and all of your driving patterns. And all of that data then fed an AI application for autonomous driving. That's why Teslas drive without you having to hold onto the wheel if you don't want to. So that company was acquired by Cisco. But what we knew, everybody at Jasper knew, was that IoT would eventually just be a source of data for AI applications. And when I talk about the data edge, that car is a great example. So in that case, the car is an AI computer, and it has to be ultra low latency for you to not get in a wreck, right? Because there's all these cameras, sensors on the car, and the AI has to make really quick decisions so that you get to where you want to go safely. So Cisco bought this company, and it's kind of one of the few executives to stick around at Cisco. And I was working in their mass scale infrastructure group on network automation strategy for their largest customers. So telecoms, hyperscalers, government agencies, large enterprises. And it was kind of a strategy role and a go-to-market role. So it was, how do we create solutions together with partners and IP that Cisco had, and then create solutions that we take to market effectively through, a really large and effective Cisco sales channel. So there's a little bit of M&A involved in that as well. And in the course of doing that, just found this market opportunity for open networking in large-scale, hyperscale data centers, and founded Hedgehog on the premise that enterprises and government agencies and everybody else is going to benefit from networking like the same way that the hyperscalers do. Hyperscalers being Amazon, Microsoft, Google. And we had this hypothesis at the time that other people would need to build out AI data centers for this oncoming wave of AI. And we had some market hypotheses about other drivers for data center infrastructure. And I'd say we significantly underestimated the scale at which people would be building out AI data centers just 3 years later.
It's a good problem, sounds like.
That's a great problem to have. Yeah.
You said that you are a startup person and you had this experience at a larger company. What benefits do you think you took from, and learning lessons you took from working at a larger company, leading the strategy into your startup afterwards?
First off, Cisco's a great company, and I've been in and out of a few different large companies. So like early search, I ended up at a company that was acquired by Disney. So I worked for Disney for a while. I started a mobile ride sharing business about 7 years too early, ended up working at AT&T Wireless to understand how cellular networks would get built out. Ran the BlackBerry business there, ended up at Amazon working on Kindle. If you look at my history, I've kind of gone in and out of starting companies and working at large companies. And the thing about big companies is they have scale, they have structure, they have capital, they have brand, they have a lot of really smart, talented people working at them. So, that experience is super valuable. And I'd encourage anybody, starting out early in their career, get a job at a big company for a while. So that you get all of that. Socialization is also another really important thing, I think, which is, becoming sort of a generational issue. And then when you have those skills and you have, sort of enough cash in the bank, then, go pursue a startup idea, because you'll have all the tools and the foundation to then go execute on your startup plan.
And in a big company, there are a lot of different experiences you can have. If someone wants a path like yours, what type of experiences or skills should they try to gain in a big company in order to help them with their startup that they'll do next?
Well, there in a lot of cases are opportunities to run startups inside of big companies. So like if you take AT&T, for example, right? I mean, it doesn't get any more big company than AT&T, but there was this little startup business around BlackBerry pagers that like eventually became smartphones. So, finding the opportunity to work on a new emerging technology inside of a large company and create a business around it that operates at scale, choose that over, in 2002, most everybody else was just, focused on selling Motorola Razr, feature phones, flip phones that you could talk on. So look for emerging technologies where, you have the opportunity hopefully to do some real R&D with a talented engineering team, or at a minimum, take another technology to market and do it at scale, which is something that a startup isn't always able to do. They may have the R&D, but they don't have the go-to-market scale.
That makes sense. That's good advice. So you talked about the problem that needs to be solved in AI. What are the requirements for an AI network today?
That's a great question. Well, most of the networks that we're building out are still for AI training use cases. So these are what Jensen calls, AI factories for building AI. That's going to change probably in the next year or two. But these are really big clusters of GPUs. So in that case, you have sort of two different networks. There's a back-end network that connects all these GPUs together. And there's a front-end network that gets data in and out of that GPU cluster. And most of the time stores that data, training data, fine-tuning data in a big storage cluster of drives that has some kind of a data platform on top of it. So there are two different networks there. They kind of have different requirements. That back-end GPU network, it just needs to be really fast. So to date, this year, it's been 800 gig fabrics. Next year it'll be double that. It'll be 1.6 terabyte fabrics. And you need to maintain that network bandwidth with that congestion management technique that I described earlier, and just the tuning technique. And then in that front end network, the requirements are a little bit different. You got to get data into that cluster somehow. So you need a gateway that connects the cluster to the internet and enables you to get lots and lots of data, like terabytes of data an hour in and out of that cluster. So you need effectively a router in and out of that data center. And we provide that with a gateway. It's a software-based router that gets you like 100 gigabits per second of data I/O with security features, right? So you need it to be, secure from hacking attempts and that sort of thing. And then once the data's in, you need to interact with these storage arrays that have sort of different network requirements. You need an NVMe fabric there. So, compute, storage, networking are kind of the three legs of the stool. And these are just super big, complex data centers. And there are very few people on the planet who know how to build them.
Yeah.
And a lot of what we do is just take like an NVIDIA reference architecture and then make an open version of that. We're an open source company.
Yeah. It seems like we're pushing the limits on what we can currently do. You said it's 800 this year, next year it'll be 1.6. What advancements have been developed that have allowed us to currently be able to push those limits?
Well, I mean, the rest of my team is on a call right now going through a cabling plan.
Okay.
So, I never really thought I'd get this deep into understanding different types of cables, fiber optic, copper, active electric cables, and then these optical transceivers that convert light into electricity. So there's a lot of complexity there, but those links are the sort of the physical links that connect all of this stuff together. And then, our software makes those physical links work properly. So there's just a surprising amount of innovation in that area, and a surprising amount of detailed planning and execution that you need to do to pull that off. And then you need to have software that just makes all that hardware work properly, which is where Hedgehog comes in. As we start getting into like 1.6 terabytes, next year, you start running into more physics problems. In fact, it's physics problems that create the need for things like optical networking, just because of the physical properties of, conductive material like copper and the amount of electricity that you have. And, what you want to avoid is in a network is packet loss, because that seriously degrades your network performance. So as we get into 1.6 terabyte, you can start running into physics problems inside the switch on the actual board. And I think you're going to see some innovations in that area as well. And it comes down to like, the level of detail is like which cable I plug into which port. So these switches have like 64 of these ports, these plugs that you plug cables into. And there's a little bit of black magic in like which cable you plug into which port to make everything work. So yeah, I think there's plenty of problems to solve there.
That's fascinating. What do you think is the most pressing future problem to solve that will make a difference? Do you think it's physical materials problem or is it software?
I think it's a usability problem. So, I mean, we all read the news. We see these, eye-popping headlines about, billion, trillion-dollar investments in these giant AI factories. People are building those for a handful of customers, hyperscalers, and people training like OpenAI who are training these foundational models. So what that means is that if you're a data center operator, you have one tenant, one person you're leasing or renting all of that infrastructure to. That's going to change pretty quickly because the goal of all this investment and training is to have agentic AI, right? Inference, applications that people can use. And when you have that, you have your tenants become AI application developers and users. That community of people, they're used to using AWS or Azure or Google Cloud, right? There's cloud infrastructure that operates in a pretty well-known, well-defined way for that community of people. The stuff that people have been building in these AI factories is not that. So what you have to do is add cloud usability on top of that really high-performance, complex AI infrastructure. And that's fundamentally what we do at Hedgehog with software. We take these really complex, high-performance network configurations, and then we make it look like AWS or Azure or Google Cloud, so that the average, software development team knows how to get access to a GPU or a cluster of GPUs and make their application work.
Yeah, so it seems like you're trying to give users a cloud experience that's actually on-prem.
Yeah.
And what exactly does that mean for you? That means, like you just said, taking all these complex configurations and making them easier to understand so that startup or company can run on-prem and doesn't need as intensive a networking team?
Yeah. So let's just start with AWS. Like the last company I started, Canvas, in 2009, we built that company on AWS, early days of AWS. And it was like game changing, right? Didn't have to go hire people to build and operate a data center. Just had one guy who in less than 48 hours, like provisioned all the infrastructure we need to build this SaaS application that people could then use to author mobile applications. Anyway, the point is that if you go to AWS, what most people do is they start with Elastic Cloud Compute or EC2. They say, hey, I need GPUs. I need B200s. You go to the AWS console, you select those B200s and you create an instance. When that happens, Amazon creates a virtual private cloud for you, and it segments the GPUs or the servers that you're renting. It segments those on the network from all of the other servers and GPUs that are in that data center that other people are using. And that network segmentation is really important. It's what makes the public cloud public. Sort of like if you're staying at a hotel, if you don't have a door with a lock, and then you're staying in a gymnasium and you don't have a lot of privacy, right? So having that room with a door and a lock is super important, and that's what a virtual private cloud does. So what Hedgehog does is we have a virtual private cloud abstraction that's in our software, and you provision it with a cloud native API on an on-prem cluster, and you do it the exact same way you would on AWS.
Yeah.
And then the next thing that's going to happen, typically if you're on AWS, is you're going to have more than one VPC in more than one availability zone, which means that you're going to then add on AWS Transit Gateway so that a VPC in, say, your West Coast availability zone can peer with a VPC that's maybe in your East Coast availability zone. And so you need to route packets over a transport network between those two locations, and you do that with AWS Transit Gateway. So Hedgehog has a gateway. We have a cloud native API. It just says, I want to peer this VPC with this VPC, and it takes care of all the routing for you. Same way it does on Amazon. That's the basic the basic cloud user experience. And then there's a bunch of stuff under the hood that Amazon or Microsoft or Google has to do to actually manage all of that physical infrastructure. Things like installing software, configuring software, applying software updates, monitoring the performance of it, tuning the configuration, troubleshooting issues, all of that stuff's automated as well.
Wow, that's so nice. I want to get into all the products of Hedgehog, but first, can you explain to me the usage pattern of on-prem, hybrid, cloud today? It seems like maybe 5 years ago, people would mostly probably be either on-prem or on a cloud. And now with AI, that pattern seems to be a bit different. Why are people wanting to have on-prem that's like cloud now?
Yeah, well, I think when you and I met at our KubeCon event, we had a panel discussion with our customer, Zipline. Florian Gartoldes are there. So Zipline is a drone delivery company. If you're in Dallas-Fort Worth right now and you order something from Walmart or Chipotle or Buffalo Wild Wings or one of these other partners they have in their network, you'll get your order in probably about 10 minutes from a drone that flies to the store, picks it up, flies back to your house, drops it off. Pretty cool AI app.
That's cool.
So they train the computer vision models that navigate those drones and handle the precision drop to your porch or your backyard. They train that on GPU infrastructure, and they, like everybody, were on AWS running it, no problem, but it was expensive. And they really wanted to have control of their data because for most people in AI, the best AI applications are ones like Zipline where you have unique data. In that case, it's all the data from those drones flying around. You want to keep that super private. Oh yeah, and Amazon's probably going to have a drone delivery business too. So you might not want to trust your gold mine with your competitor on their infrastructure. So cost and control caused them to invest in building their own private AI cloud. And when they did that, they had control of their data and they cut their infrastructure expense by 70%.
Yeah, that's a good reason as well. At Bloomberg, for example, I know that we were traditionally on-prem, and I think some people are also seem to be going the opposite way. For on-prem, of course, like you said, you have costs and control and privacy, but for resources, we also became multi-cloud. But I could imagine a lot of other people doing AI that were one cloud provider became multi-cloud, and maybe they also want to be on-prem now that it's so easy. If they're large enough, if they can have the resources to manage that, since managing it now is a bit easier, that's also desirable for people running AI workloads.
Yeah. Look, we founded the company with the premise that it's a hybrid multi-cloud world. So people probably, just like I did in my startup, start off on one cloud, super easy, super convenient, pay up for the convenience charge, focus on my core business of understanding my customer, building a product that meets their needs. As I start to scale, maybe I add a second cloud or a third cloud. And then when I'm operating at scale and I need to now start not just proving a top line revenue growth, but actually, generate free cash flow, earnings, for shareholders, then I start optimizing cost.
Yeah.
And I start running more hybrid cloud. The thing that's different with AI is the infrastructure cost is significantly higher than internet or mobile applications that have preceded it, like by an order of magnitude.
Do you think that will change?
Yes, I think the techniques that the data science techniques that people use to create AI models will evolve for sure. They have to be more efficient. They'll get more efficient. The planet just isn't going to produce enough power on the current path. So there will be efficiencies that way, but still your infrastructure cost is going to be significantly more for an AI application than web or SaaS or mobile applications that have preceded it, which means that as a CEO or as an investor in an AI company, you really need to think about your AI infrastructure strategy from the start. And the sooner you take control of your AI infrastructure, you build a moat with unique data. That is your moat, is your data, and you reduce your costs, you will have a viable, sustainable business for the long term. If you don't do those things, you might raise a lot of venture capital in the next year, but you'll probably burn through it and not be around in a couple of years.
Yeah, that makes sense. You said you made assumption that people will be in this hybrid cloud on-prem environment. What support does Hedgehog have for the hybrid environment?
Yeah, so when I was talking about our gateway and that cloud native API to peer VPCs, you can peer Hedgehog VPCs with each other in different locations, but you can peer a Hedgehog VPC with an Amazon VPC or an Azure
Mm.
VPC or a Google Cloud VPC pretty easily.
Yeah, nice.
So yeah, that's hybrid cloud.
Yeah, make sure it's compatible.
Yeah.
So talk to me about all the different products that Hedgehog has. I was looking on the product page, and some of these you've mentioned already, but just to be clear, it seems like it's virtual private cloud, open network fabric, gateway, zero touch lifecycle management, open observability, and then you also had a tab for supported devices.
Yeah, I feel like maybe you could help us with some product marketing.
Yeah, me?
Look, we have one product. It's Hedgehog. It's a turnkey software appliance that gives you everything you need to run an AI network. It's open source, and it has a bunch of different components that we've been talking about throughout the course of this. So we talked about this virtual private cloud user experience, this construct. That's the user interface, if you will. We talked about different AI workloads that we've generally categorized into training, fine-tuning. You can kind of have RAG as a derivative on fine-tuning, inference, and then people are still doing general purpose compute as well. Those all require different network configurations. And in the data center networking world, people call that a fabric. When you look at all these cables, they're connecting all these ports together. It looks like threads in a fabric. So we productize those, right? We talked about a back-end GPU fabric and a front-end IO storage fabric for AI factories. That's an example. It's productized, so it configures out of the box. We talked about peering virtual private clouds with each other using this gateway. The gateway it's software that runs on a server that has an NVIDIA network interface card in it. It's called a ConnectX SuperNIC. And we program that thing so that we can turn a server into a router and a firewall. So it means that you don't have to buy a separate router from somebody like Juniper. It means that you don't have to buy a separate firewall from somebody like Palo Alto Networks. You just have this software solution that includes all that stuff, and it operates the same way that AWS does, right? You're not buying routers or firewalls when you use AWS. Same thing. We talked about how under the hood, there's a whole bunch of stuff that we have to do to manage the physical infrastructure, the hardware, the same way that Amazon or Microsoft or Google do, the same way hyperscalers do. And that's, there's a page on our website about zero touch lifecycle management, but it's automating that. It's automating the day zero installation of all the equipment and the software and the day zero configuration. It's about day one, which is I'm onboarding tenants and I'm enabling them either through a console application that uses our API or directly with our API to get access to compute and storage resources that they need. So doing that in a secure, automated fashion. And then, it's day N, which is observing all of that. So monitoring, we call it telemetry, but it's log files that are coming off of all these network devices. It's flow data, so just information about how packets are moving across the network, and putting those into dashboards, reports, so that you can see the performance of your network. You can identify anomalies in the network. You can identify faults and troubleshoot issues so that everything stays up and running at optimal performance. And that's what we generally call open observability. And then the last thing, and this is kind of one of the hardest parts of what we do, we need to get all of that software that I just described working with hardware. And in networking, like every network device has its own idiosyncrasies. And I mean, that's why incumbent networking vendors like Cisco or Arista or Juniper are multi-billion-dollar businesses, is because there's just a lot of complexity to manage there. So what we do is we support a list of devices that are on the website. And we do that by getting that device into our lab and testing our software on it every day, all day. So continuous automated test to validate that it works properly. And then if you are a customer of ours and you report an issue, we're able to reproduce that issue on the same hardware environment that you have. And when we troubleshoot the issue, maybe in our software, but it may be how our software interacts with that hardware. So we have a relationship with those hardware partners where they help us solve those problems for customers. And that takes a lot of work, to be perfectly honest. And that's the commercial model for Hedgehog, is you pay us for all that work.
Wow, that sounds like it takes a lot of work. Is this supported devices feature and all the testing and support that you provide, is that typical in this field? Do your competitors also provide that, or is it something that is extra and sets you apart?
Great question. So if you look at the way networking's been done historically, everything's vertically integrated. So like for AI, most people today will go buy an NVIDIA network, right? So you get an NVIDIA switch, an NVIDIA NIC. It comes with an NVIDIA operating system called Cumulus. It doesn't have all of the automation stuff or the cloud native user experience that we've been talking about, but you're getting it all from one vendor. And the same thing is true with Cisco or Arista or Juniper. And in the case of Cisco, where I used to work, there's a portfolio of applications automation that was designed 10 years ago for data centers to automate stuff. But what happens is when you choose one of those vendors and everything's vertically integrated and it's proprietary, you kind of get locked into that one vendor solution. And they kind of create that lock-in also by training network engineers who know how to use that particular stack, which can be good, but until maybe you need to renew your contract and you're in a price negotiation, and then you have zero leverage. Yeah. So part of what we say when we say, hey, we enable enterprises to network like hyperscalers, is we kind of break the mold on that. And we enable the average enterprise to do what Amazon or Microsoft or Google does, which is you use open source software that then enables you to choose hardware from whatever vendor you want based on price, availability, performance, which matters a lot if you want to have an elastic supply chain that's resilient to supply shocks like a COVID pandemic or tariffs, supply shocks that prevent you from getting equipment when you need it. And so that's one of the things that we're doing differently is we take the same approach to a network operating system, to network automation that hyperscalers do. And not just for the user experience, but for everything underneath it, so that you can be price competitive in the market because you operate at a low cost, right? Hyperscalers have to operate at low cost to be able to compete. So do neoclouds. We haven't even talked about neoclouds yet. That's a really good topic. And you need to be elastic. Elastic cloud compute requires an elastic supply chain that's diversified. And I mean, you're in the financial services business, right? How do you manage risk? You diversify. And so same thing here is technology risk. You diversify.
Yeah. Well, why don't you explain what neoclouds are?
Yeah. So, because I think one of the questions you sent me is like, hey, what surprised you? I honestly, I didn't see the neocloud thing coming. I figured, enterprises are gonna do hybrid cloud services are gonna stay in the domain of the big three. Maybe there's a fourth with Oracle, and that's it. But what's happened is there's this whole crop of new companies that have arisen that run AI infrastructure and sell it as a service, either to a hyperscaler or to somebody like OpenAI who needs a lot of infrastructure to go train models, or in the future to enterprises who, I've got a project to start doing AI inference, but I just don't know how to go build out all of this AI infrastructure and it's kind of expensive. So I'll outsource it to you. So CoreWeave is kind of the flagship example. They went public, I think in March, and had a really good IPO. It's like a viable business operating at scale as a public company. And there's now, if you look at Semi-Analysis, which is kind of an analyst firm that covers neoclouds, they cover something like 200 neoclouds.
So these are basically smaller cloud providers that are focused on AI.
Yeah, that's right.
And so this is probably great for your business as well.
Yeah, it's great.
Yeah,
for sure, it's great. Yeah. So I mean, we have a product that's like designed kind of perfectly for it, right? So if you're a neocloud, you can go out and buy a reference architecture, a proprietary reference architecture, and have something there, but you're going to miss out on cloud user experience for multiple tenants, which is going to be more and more important for inference. You're going to miss out on low cost operations, and you're going to miss out on, resilient supply chain that grows elastically, unless you start working with Hedgehog.
You say you're surprised by the rise of neoclouds. What do you think has led to their rise? Why are they now becoming popular?
Oh, I just think insatiable demand for AI infrastructure. And I think the AI bubble is a topic, and I think that is a real thing, having been through the Internet 1.0 bubble. Part of what's been driving that demand so far, I call it sort of Bing 2.0. So like very early in my career, in late 90s, I was at an internet search engine called InfoSeek, pre-Google search engine. There were, I don't know, at least five internet search engines before Google, right? And then eventually there's a bunch of consolidation and the internet bubble burst, and out of that came Google, and they consolidated what we used to call back then the internet portal. But the Google search prompt for the last few decades has been the portal to all human knowledge. Well, all of a sudden, OpenAI came out and kind of changed that paradigm. And boom, Internet Search 2.0's on, and Microsoft goes all in. Like here, Bing 1.0 didn't work out, but maybe this time around we become the fold to human knowledge, right? And hence the OpenAI relationship. And that's just created it's a geopolitical land grab for AI. That's creating a huge amount of demand for AI training infrastructure that no one company can fill. And so it's created this market of neoclouds. That's going to change. We talked earlier about training techniques getting more efficient so that you don't need as much infrastructure. And then just the natural evolution. These things should evolve from training new models where, every model sort of reaches some kind of an asymptote on quality and there's less variance amongst them. And then, it becomes more inference and more model types for different cognitive functions. Right now, we focus on things that can chat with us or maybe create an image or a video for us, but there are a lot of other cognitive functions out there. We talk about driving or flying, or there's other things too.
Yeah, that will be an exciting time.
Yeah.
I also, you have focused on open source and cloud native. Can you also talk a little bit about the decision to go that route and what the implications have been?
Well, yeah, I think I mentioned it, it's sort of fundamental to the idea of networking like a hyperscaler. If you look at the big three, they all do everything with open source. So we started with a project that Microsoft started. It's called Sonic. It's an open source network operating system. Google uses it now. Meta uses a variant of it. Alibaba uses it. And that kind of follows on another project called Cumulus that Amazon uses. And then we did all this R&D around that project with Hedgehog to create all the usability stuff and automation stuff that I described to you. So, that's the key to networking like a hyperscaler, is to do it in that fashion. It's a little bit crazy, right? Because here we are doing that in the face of well-established businesses, incumbent network vendors that will be threatened by open source. They'll have to change. They're facing the innovator's dilemma, right? Which is lean into it to change or, sort of face disruption. And so, most mature businesses resist that, right? You maximize profits for shareholders by defending your legacy business as long as you can until you can't anymore. So that, that's made getting to market a little bit harder, honestly. But, the good news is there's this thing called the Open Compute Project. It was started by Microsoft and Meta to create an ecosystem of equipment vendors who could meet their needs with, hardware that is designed to open specifications. And so what that's created is an industry of, people will call them white box vendors, but they're people who design a product in partnership with Amazon or Microsoft, Google or Meta, a hyperscaler. It goes through an open review process at OCP. They build it in massive quantity for those hyperscalers. And then, a little bit on the side, they sell to enterprises.
Yeah.
But to do that, they need software. And so, we've established really great partnerships with some of those OCP vendors. And because they manufacture at a very massive scale for hyperscale customers, they're very efficient. It ends up being really good for an enterprise customer. They can acquire equipment with much better pricing than they might get with something that's more proprietary.
Yeah. Big fan of the innovation and community of open source.
Yeah, for sure.
So as a founder, what do you think has been the hardest part about building a networking startup in this AI era?
I've been talking about Arista. If you look at the ANET share price, I think today it's trading at around $163 billion market cap. It's a pretty healthy market cap. That company, it didn't take venture capital investment other than from the founders. And I think part of it was sort of the same phenomenon I just described to you, which is like most investors are like, that's crazy. Why would you start a new networking company when Cisco basically has a monopoly? And they focused on the data center cloud use case, serving Amazon and Microsoft and Google, and created this really massive business out of it. So, I think what's a lot easier investment for a lot of venture capitalists is who sort of have in the previous cycle of investment invested in B2B SaaS, which was, an enterprise version of a consumer internet application. It's easier to understand the evolution of that into a vertical AI application that just adds some AI features into that SaaS product. It's something that more people can understand. Understanding all of the technology in AI networking is not easy. There just aren't a lot of people that understand how to do that or want to understand how to do that. Or maybe they understand it, they don't want to accept the technology risk on it, or they don't want to accept the market risk of being a disruptive technology. So that's fine, actually, because I've done this a few times. And I've been in a situation at a company that somebody else started where we were just overcapitalized. We took too much venture capital in. We developed a lot of bad habits. We spent a lot of money, and the valuation got ahead of where the business fundamentals were. Sort of like the government, right? Like once you start deficit spending, it's pretty difficult to balance the budget.
Yeah.
Right? I'm not counting on the government doing that anytime soon. So if you have the discipline to bootstrap a company, the same way the founders at Arista did, and focus on a particular use case that's big and growing fast, which AI infrastructure is, and you develop good habits along the way, you focus on customers, you build a fundamentally viable, solid business that generates free cash flow in addition to revenue growth. And if you do that, everybody's going to want to invest in you. And then you're like, maybe I don't need your investment. And you just keep focusing on customers.
That sounds like a great place to be in.
Yeah.
Looking back on all that you have accomplished at Hedgehog, how long ago did you start Hedgehog, by the way?
I started the company in June of 2022.
Nice. So in the last 3 years, what would you say is the accomplishment or decision that you're proudest about for Hedgehog so far?
Oh, it's an awesome team.
Yeah.
So we're 11 full-time employees. I'm like the only employee who's not a viable engineer. Everybody else is like a world-class engineer. So yeah, I'm most proud of assembling that team, of holding that team together through what is for most startups is a long R&D cycle. It took us a year to build the fabric and the network controller and the cloud native API. It took us another year to build this gateway, this high performance router. I mean, that's 2 years of like intensive R&D. And then there's the company inception stuff that came before that, and recruiting and assembling the team. But, 2 years of intensive R&D with world-class engineers is expensive, particularly expensive if, everybody's investing in AI applications and token wrappers and stuff like that. Bootstrapping through that and getting to market with like a really good product that has empirical results independently tested and verified by third parties with super happy customers that are glad to give testimonials. That feels pretty good.
That should feel pretty good. Congratulations on that. And looking forward, what problem are you most excited to solve next?
Oh, we're super excited to just see this transition from training to inference. Just more enterprises sort of having clarity on things like model selection, use cases, return on investment, investing in the same kind of AI solutions that, innovators like Zipline have, right? And when that starts happening, it's going to be super fun.
Yeah, I've worked pretty directly with the translation logic for provider model and then also cloud providers for all the different models. And there's a lot going on right now. So I think it'll be nice when things are clear and people have a clear idea about how to select their models. This one's thinking, this one's not. This provider has these values, these are numerical. This provider is low, medium, high. For me, in the details of it, even that is a lot to manage.
That's a huge problem. And we didn't really talk about this, but like a lot of these neoclouds, the ones that will succeed over the long term are people who do the same thing that hyperscalers do, right? They start with infrastructure and then they start adding platforms on top of it. So model curation. And I think as we get into inference, there will be different types of accelerators, GPU alternatives that are sort of matched to different inference model types. Like we saw this recently in the news with Google's TPU deal. There'll be more of that kind of stuff. People who do that well and reduce the complexity for the AI developer are going to have really healthy businesses. And we're happy to support them with just this boring old networking stuff that we do under the hood.
Yeah, that's amazing. So That's all the questions I have for today. Are there any last words or piece of advice that you would like to leave for our listeners?
No, I think that's about it. Look, you did a great job at this interview. You prepped it
Thanks.
well. You asked great questions, and I just wish you luck, with your podcast.
Thank you. I appreciate it. Thank you so much for your time, and thank you for coming on. It was a great and very informative conversation.
All right. Take care, Alexa.
Thank you so much for listening to Alexa's Input AI. And if you want to follow along with my new episodes, writing, content, everything I'm building, you can find me at alexagriffith.com, on Substack, on YouTube, or wherever you listen to podcasts. If you enjoyed this conversation, it would mean a lot if you subscribed, shared this episode with a friend, left a quick rating or a comment to help more people to discover the show and keep these conversations going. Again, I'm really grateful you're here. This podcast started as a side project for me a few years ago, and every listener who reaches out or keeps coming back reminds me exactly why I love doing this and I love putting so much time into it. I hope this episode gave you something to think about, something to talk about. So always stay curious, stay grounded, and I hope to see you next time. Thank you for your support.